Bismillahirrahmanirrahim. I welcome you all to the ninth lecture of the Electromagnetic Theory 1, EMT 1. Today we will talk about the Dirac delta function and its properties. My name is Muhammad Sajid and I am Assistant Professor at the Department of Physics, CUST. So we will start with the divergence of a special function, which is r over r square, r unit vector divided by r square, which is pointing really outward and is decreasing with the square of the distance from its source. I will start with the one-dimensional Dirac delta function and will discuss its properties, and at the end of the lecture I will solve some examples involving delta function to let you know how you can solve problems or examples involving delta function. So I will start with the divergence of r over r square. So let we have a function which is r divided by r square, and we are interested to find its divergence. So because the function is in spherical polar coordinates, so we can use the definition of del operator, the divergence in the spherical polar coordinates, which is 1 over r square d by dr r square r unit vector dot the vector function v, which is r unit vector divided by r square, and hence you can write as 1 over r square d by dr, and it will be r square divided by r square. We have r dot r. So divergence of v is 1 over r square d by dr of 1, which is 0. So divergence of v is equal to 0. But this result is quite strange, that divergence of this function, but you can clearly see that this function is pointing really outward and it has some divergence. But yeah, from this expression we can see that this is equal to 0. So yeah, we want to see that how what is the problem with this function, or what we are doing wrong. So yeah, okay, so this is equal to 0 and we have to find why this is equal to 0. So we can use the divergence theorem for this vector function v. Say from divergence theorem for this v, we can write that volume integral divergence of v d tau means this volume element, and this is equal to the closed surface integral v dot dA. So if we apply this divergence theorem to this function, then yeah, from the right hand side we can see that since divergence of v is equal to 0, so this will be 0, and we have to check that whether it's equal to the v dot dA or not. So v dot dA, so v dot dA over a closed surface. So let's say we divergence of V over volume theta is equal to V dot dA over surface. So divergence of V volume integral theta is equal to the closed surface integral. Yeah, so I have to end short here because I have little problem. I have to remove this and this as well. I'll write like this. So we divergence of V volume integral V dot dA surface integral. So this is 0, we know already, and we have to find this closed surface integral V dot dA. Since V dot dA, we have to integrate this over a closed surface, and the closed surface we can take a sphere of radius r, which we can write as r over r square close, and dot product with the area element, so the surface of a sphere, so we can write r square sine theta d theta d pi and r unit vector. You know from our previous lecture we can write the area element in the for the surface of the sphere, so there is no integration on the r. So this will be from 0 to pi for theta, 0 to 2 pi for pi, and here actually we will use r square, and small r will also be capital R because we are taking the value of the vector function at the surface of the sphere. So this will be r square over r square, and this is sine theta theta d pi. Yeah, so this will cancel out and we will get 0 to pi, 0 to 2 pi, and sine theta d theta d pi, and if you integrate this you will get for pi. I think you can easily do this integration. So here we will see we are now we can see that this was 0, but this is equal to 4 pi, which is not equal to 0 actually. So in the right hand side of the divergence theorem gives us 0, 4 pi, and the left side gives us 0. So yeah, there's a problem. And what's the problem actually? What's going wrong? We can suspect either the divergence theorem that it's not correct, or there is something else we have to find out, and this is quite clear. we know that the divergence theorem is correct, and yeah, there is something about the divergence of V. Why this is giving us 0? So I will give the answer in the next video clip. So let's go to the next video.